90 degrees.
90 degrees? Okay, does everyone agree with Matt that if I measure angle ACB, I get 90 degrees here? Yes or no?
Matt's the only one that nods.
Yeah.
Yes?
I don't know, I can't.
Okay, so when I'm trying to measure this, I grab my protractor, I place this little crosshair in the middle of my protractor. That's what's going to go on angle C, and then I need to line it up. So I can either line this arm up so that it matches up with AC or matches up with CB. It doesn't really matter which one, but then from here I'm going to calculate, or I'm going to look at going to the other line, which is right here, and then I read my angle measurement of 90 degrees. Is that clearer now? Clear as mud? Okay, so now what I want you to do is pick a point D on the circle. I don't care where D is.
So where do I put it?
On the circle. On the circumference of the circle, Dylan. Then what I want you to do is connect this point D to both A and B using the straight part of the protractor as a ruler. And then use the protractor to measure what is angle D. So what is the measurement of this angle that you just created? Okay. Pick two more points and do the same thing. Bet you're going to be 90? So from these four triangles, these four angles that I've drawn, C, D, E, and F, what conclusion can you make based on this? They're all 90-degree angles. So what can you tell me about how to draw these angles? Like, does it matter where A and B were? Or what can you tell me about A and B, that line? It's the diameter, because it goes through the center of the circle. So I can say that an angle drawn, and I have to be more specific here, on the circumference, because when Dylan asked me where to put the point, I had to say on the circumference of the circle. So an angle drawn on the circumference of a circle through the diameter will have a measure of 90 degrees. So the angle is on the circumference of the circle and it had to go through the diameter. So you're going to find this chapter a lot different from a lot of the math that we've done so far because it is mathematical reasoning. So a lot of it is logic, a lot of it is drawing conclusions based on observation. So if I look at the second part, Bruno's investigating a fabric design for a new furniture he's making. The original design is based on the trapezoid. So his first two complete sketches and a third incomplete sketch are shown. So how did he get his first sketch? What did he do? What did he do, Lane? He added 2 more trapezoids, smaller trapezoids, and he connected them to the top part of my trapezoid. He did the same thing in sketch 2. 2 more smaller trapezoids, 2 more smaller trapezoids. So guess what's going to happen on sketch 3?
2 more. Inside.
There's going to be 2 more on each side, so sketch that in. Take a moment to sketch what that would look like. Something like that. So Bruno wants to know how many trapezoids he would add in the 5th sketch without having to actually draw the 5th sketch, because my trapezoids are going to start to get pretty small when I get into the 5th and the 6th and the 7th sketch. So if he looks at creating a chart, in the 1st sketch he added 2 more trapezoids. In the 2nd sketch, how many trapezoids does he add? Okay, so I want you to complete the chart. So in the 3rd sketch, how many new trapezoids did I add?
8.
8. So in the 4th sketch, how many do you think I would add?
6.
So then in the 5th sketch, I would add?
32.
And in the 6th sketch, what would I add? 64. So based on your table, how many trapezoids do you think I would add in the 10th sketch? Without having to go 7, 8, 9, 10. How could I skip from 6 to 10?
32 times.
But what if I didn't know that 2 to the power of 5 was 32? Or this one right here. What if I didn't know that in the 5th sketch I was adding 32? What's happening each time?
Timesing it by 2.
It's timesing it by 2. So everything is a power of 2. 2 to the power of 1 is 2 to the power of 2.
4.
What's 2 to the power of 3? Check it on your calculator. What's 2 to the power of 3? What's 2 to the power of 4?
8.
Yeah. And then 2 to the power of 4? And 2 to the power of 5? So in the 10th sketch, what would I calculate? 2 to the power of 10. And what would 2 to the power of 10 equal? Okay. These are examples of inductive reasoning. So inductive reasoning is drawing a conclusion, a generalization, or an educated guess based on observed patterns. So the first example, we drew some angles through the diameter of a circle. We found that those angles always equaled 90 degrees. That's inductive reasoning because we only drew 4 of them. Okay? The conclusions to the investigations are called conjectures. A conjecture is a conclusion, generalization, or educated guess which is arrived by inductive reasoning. So our conclusion that in the 10th sketch I would have 2 to the power of 10 or 1,024 additional trapezoids added, that was a conjecture. Using tables when determining conjectures is strongly encouraged. Conjectures could be true or they could be false because a conjecture is just based on the inductive reasoning. And so with the examples, I've only figured out up to 2 to the power of 10 or up to 2 to the power of 5. Or I've only drawn 4 angles in my circle. I would have to draw several more in order to base that conclusion and turn it into something that is more so fact. So I'm going to give you a moment. I want you to explain how you used inductive reasoning to arrive at the conjecture in part 1 and how Bruno used it in part 2. And then we'll discuss the answers. Okay? So how did I use inductive reasoning to arrive at this conjecture? I drew some angles. They all equal 90 degrees.
Oh no, I don't think that works because we have to do T4 divided.
So all my angles drawn, how to measure of 90 degrees. Bruno used inductive reasoning to arrive at conjecture from part 2 of the investigation. What did he do?
He did draw trapezoids.
He just drew the trapezoids, and then from his chart, Bruno saw that the number of trapezoids, or the number of new trapezoids, doubled each time. Which then allowed him to extend the pattern. So what I want you to do is I want you to use that information, and I want you to do question number 1. The idea of inductive reasoning and conjecture.